All right, so back to talking about constructors. All right, so we talked about how you can use the this keyword for this parameter in a constructor, and it's very common to do that because one of the most common constructors to write, for example, if I had this little example here with foo, is I'll almost certainly have a constructor that lets me set both of those fields explicitly. So I will have public foo, and then I'll take two parameters, int f, string name, and you'll notice I've given the parameters the same names as the instance variables. That's a very common thing to do. And so then I'll have this dot f gets the parameter f, and this dot name gets the parameter called name. So you'll see a lot of, in other people's code, you'll see this pattern done quite frequently. All right, get rid of this stuff here now. All right. So, next thing is, in almost every class, almost without exception, you're going to want to provide a no argument constructor. So a constructor that does not take any parameters. The reason why you want to do that explicitly is it'll help you avoid some really kind of mystifying compiler complaints later on. If you don't provide any constructors at all, and in fact, of course, all the examples that we've generated so far in this class, for classes, we did not have any constructors. So how did that work? The way it works is that Java gives you a free default constructor that takes no arguments. Right? And so if you don't provide any constructors at all, you're still going to be okay. You'll be able to make instances of the class. So, and you can call new, and you'll say the class name, and you won't provide any parameters, and that has worked just fine for us for the past 2 weeks, 3 weeks, no problem. If, however, you provide any constructors explicitly, like this one here, then Java won't give you a zero argument constructor. It'll just sort of assume, okay, that's the only constructor they want, so I'm not going to make another one if he doesn't want to. And that's not going to bite us in the ass yet, but it will when we get to chapter 6. We start working with arrays, as we will see. So, in general, whenever you make a constructor, you always want to have a zero argument constructor as well. And it's usually pretty easy to do, because what you'll typically do is you will have your zero argument constructor invoke a constructor that takes more parameters. So in this kind of silly case I have here, I will create a zero argument constructor. It's also called foo, but it does not take any parameters. All right? So typically what you want for this is, these are like, what do I want the default values of these to be? Right? You've got to give them something. So you could do it this way. I could say, for example, well, f gets, I don't know, maybe we say 0 is the default here, right? And name, maybe I'll just call it default. And so I could write it out that way. Perfectly fine, zero argument constructor. But there's a little bit easier way to do it. Because see, I already have a method up here which basically does exactly this. Sets f to be this parameter and sets name to be this parameter over here. So what I really want to do is take advantage of this code I've already written. And so a very common thing to do with constructors that take fewer arguments than other constructors you have is you have the constructor that takes few parameters do its work by invoking a constructor that takes more parameters. And that looks like this. So here I had 0 in default. So I'll change this up. And I will instead, syntax looks a little weird. I'm going to say this, and I'll pass in 0 and default, like that. And that does exactly the same thing, but with less work. So this is the first time we've seen this use of the keyword this here. Okay, so this is basically how you can invoke other constructors within a constructor. So the compiler will say, will know this is first of all in the body of in the definition of a constructor, and when it sees the keyword this and paren, it says, okay, the programmer is looking to call another constructor, and I can tell which one of the overloaded constructors by looking at the types of the parameters. So the first argument is an int, the second argument is a string, and that matches this signature up here of this constructor. So I'll just have this constructor invoke that one for me to actually do the work of initializing the fields. Right, and I could have had another example. Maybe I want yet another constructor. Maybe it takes a single argument. Let's make it an int f or something like that. And again, I could also call it the same thing. I could say this, and I'll pass f in as the first argument, and again, I'll pass in default as the second argument. So again, I'm just making use of this code that I've already written up here. The non-allowed we user to specify one of the values that's going to go into my instance variables up there. And again, right when the compiler sees if the f here, it's going to be this variable here. If you meant this.f, you would have to write out explicitly this.f, and then take the existing field and write it in. It would be silly, but you could do it. All right, so let's take a look again at the date class. Just you see, now we've covered some of the terminology. So let's go jump back to the date class. Again, this is all in your textbook. You can look it up. And I've changed up the code a little bit from what's in the textbook. So I changed the zero argument constructor to use the technique I've just discussed, the use of the keyword this there to do the work of initializing the month, the day, and the year. And all the rest of the date methods, I think these are all the same as they are in the textbook, where they actually use this helper method called setDate to do the work, and setDate's been overloaded, so I can either take the month as a string or the month as an integer and kind of do the right thing. So they're all basically taking use of these setDate methods down here, again, to kind of set all the possible values. You'll notice here, so these constructors here both call setDate, right? And you pass in either an int or a string as the first argument. So there's two different setDate methods. They've been overloaded. So if you look down here at the setDate here, they have very similar structure. The only difference is what the data type is of the first argument. But in particular, they both call this other helper method called dateOK. And really what they're checking is to make sure that you don't set a date which is illegal, like February 31st or something like that. So dateOK just checks whatever values the user has provided, the caller has provided, are legal. And so that method is down here. We've actually looked at it before. I'll just remind you. So here it's kind of lengthy, but where's dateOK? DateOK is down here. So it checks, right, is the month valid? Is it between 1 and 12? Is the day between 1 and 31? Is the year the right dates? I guess they haven't checked for the number of days in the months. That's fine. But that's the kind of check that you would make, the dateOK. So here's the month. Okay, there it is there. So check the month's act is correct. So the month has to be one of these 12 strings. If the date is not legal, right, then the author has chosen to just terminate the program. Not a very helpful error message, by the way. It should really say something like illegal date and then terminate the program. But so anyways, there's just ways to deal with constructors that fail. All right. Okay, a copy constructor. So I've included in, I don't think this is, I can't remember how they did it in the textbook, but I've basically made a slightly different version. There's actually, so a copy constructor simply refers to a constructor for a class, which takes a single argument, which is an instance of the same class. And we call it a copy constructor because what you're trying to do is make a copy of an existing object. Which means I want the instance variables to be the same in both objects. So that's what I mean by a copy constructor. And this example on the slide here kind of shows a simple way to do that. So if I had a class called date, I could just have a constructor, has the same name as a class, of course, and you can see it has this parameter, which is another instance of the same class. And so what you're going to do then is you're going to set the instance variables of the new object, the one you're constructing, to be the same as the instance variables of the parameter which is passed in. So over here, the next slide was there. Yeah. So let's take a look. So if I had this field here, let's add let's assume these are all here. So I wanted to make a copy constructor for this. Public foo has to take another foo object. I'll just call it ridge. Okay. And then I could say f gets ridge.f and name gets ridge.name. So constructors, they'll usually look like that. Right? So let's kind of think about, well, how does this work? What does it do? So I'm in some other class someplace, and I'm going to make one of these foo objects. So I'll say foo Matt gets new foo, and let's assume I still have the constructors I showed you before. They're still there. So in particular, I'll pass in, say, 10 for the value of f, and I'll pass in Matt as the value of the next. So I call that. So this invokes the constructor that takes an integer and a string, and again, it's a cookie cutter, so it goes ahead and it carves out a chunk of memory. So here's Matt. So the new method caused the cookie cutter to hack out a chunk of memory big enough to hold an integer and a string. And then the constructor then places a 10 in the field, the f field that contains that. So it's labeled as f. This is name over here, and puts the string Matt in here. And then the assignment operator changes Matt to reference this chunk of memory. Okay, step 1. Step 2, make another foo object. So let's make this foo Kathy, and foo is new foo Matt. Right? So this has a parameter that is a foo object, so it's going to invoke this constructor. So the first thing that happens is new occurs. It takes this, the cookie cutter, it cuts out a piece of memory. It's big enough to hold an integer and a string, labels that f, labels that a name. Right? And then we're in this method. My job is to fill in these two boxes. So ridge is this parameter here is mapped to this argument over here, Matt. So just to make it explicit, I'll go ahead and I'll say a ridge is pointing to the same chunk of memory that Matt is pointing to. Right? And so this parameter is implicit. I didn't actually use the keyword this, but it's there. So this is pointing to the brand new chunk of memory, which the new method has carved out. And so now I want to set the f field of this, that's this f field over here. I'm going to set it equal to the f field of orig, that's this f field here. So it's going to copy this 10 over here. And then it's going to copy into the name field, which is here. It's going to take the name field of orig. Well, here's orig. Here's the name field. It's going to take this string, and it's going to copy it in over here. Like that. And then I return. And now that I've got the object, the assignment operator is going to cause the variable Kathy to refer to that new object that I've created. Now, it's important to keep in mind that although they look the same, they're actually two different locations in memory, completely independent from each other. So changes I can make to Matt won't make changes to Kathy and vice versa. Okay. Last slide. Default variable initializations. You actually, as I said before, you don't have to have constructors because you get one for free. Right? As long as you don't provide any constructors at all, you get a free constructor. Right? And so you might say, well, how does the default work? What does it do? Right? Well, basically what happens if I have no constructors at all, so let me get rid of this one. Then the default constructor assigns values to all the instance variables. And basically what it tries to do, if it's a number, or anything like a number, basically any of the primitive types, it will assign it the equivalent of a 0. Right? Booleans are assigned to false. And all class types, like the string object up here, will be assigned null. So that's the default. Booleans are false, everything else is a 0 or as close to a 0 as you can get, right? And strings are null. And that's why, by the way, when I was in, let's pull this up example in, I showed you this in BlueJ before. Move this into the screen so the folks back home can see what we're doing. I think it was, let's look at date. Oh no, it's probably third or fourth try would be okay. Let's look at this guy here. Yeah. So this is earlier on in the chapter. We had an implementation of the date class, and there were no constructors here because I hadn't got to that part of the chapter yet. And so this compiles, no problem. And when I pull up this, so when I say, and you can do this in BlueJ, it's a nifty little trick, you can invoke new, right? And you'll see that this is calling a constructor which actually takes no parameters, so it's going to be the default 0 argument constructor. So I can do that, and I give the instance a name, and it'll use the default. And that shows up down here in BlueJ. And if I right-click on that, so if I double-click on that, it opens up the object and it shows you the values of the instance variables. And now you can see the defaults, right? One of the instance variables is called month. It is a string, which is a class type. So it gets the default value of null, meaning there's no string. And day and year were both ints, so they're set to 0. That's the default value you get when you're initializing instance variables. Now, very important, it's not that big a deal because the compiler will always warn you. You only get this automatic initialization of instance variables. It does not happen for local variables. So when you declare a variable inside of a method, you have to give it a value before you attempt to use it. Otherwise, the compiler will complain. So again, I have a method in here called black pen so you can see what's happening. I could say public, I don't know, void, fun, that. I can do a local variable, int x. Okay, so there, I've declared the variable, but I haven't given it a value yet. X is not 0. Right? It has no value at all yet. If I try to do something with it, like say system.out.print x, you'll get a compiler error. It'll tell you you're trying to use an uninitialized variable. So not 0. So if you want it to be 0, set it to 0. Now you're good to go. Okay? All right. Okay. So that's it for the material I wanted to cover today. So the rest of the time is to run the My Programming Lab practice session, and let me know if you have any questions about the programming assignment lab thing you're kind of working on now that's due tomorrow, and we can go from there. But we're done. So any questions, Kathy? No? Okay, good. Then I'm going to shut this stuff down. And